freezing point. Okay, we are discussing about depression and freezing point. Okay, what do you mean by this depression? Okay, what do you mean by this freezing point or melting point? Means the temperature at which a given substance can simultaneously exist in both solid state as well as in liquid state. That particular temperature is called as what means freezing point or melting point we are calling. Okay, at that particular temperature, okay, vapor pressure of substance in liquid phase as well as the vapor pressure of substance in solid phase both will be the same. Okay, at freezing point or melting point temperature, liquid state of the substance as well as the solid state of the substance both are having what means same vapor pressure. Okay, that particular temperature is called as the, okay, that particular temperature we can call it as what means freezing point or melting point. Yesterday we discussed a few things. Depression in freezing point, what is the formula we are having is delta TF is equal to T naught F minus TF. Delta TF is equal to formula T naught F minus TF. That means freezing point of pure solvent minus freezing point of solution. And one more formula we discussed, depression in freezing point is equal to Kf into M. Kf into M is the second formula we learned yesterday. Delta TF is equal to Kf into M. Depression in freezing point is equal to Kf into molality. Whereas Kf is a constant, you know about it. It is called as the molar depression constant or cryoscopic constant we can call. Molar depression constant or cryoscopic constant. Next, one more formula we learned. Delta TF is equal to Kf into, delta TF is equal to Kf into weight of the substance by molecular weight of substance into 1000 by weight of solvent in grams. 1000 by weight of solvent in grams. So these are the formulas we learned yesterday regarding the depression in freezing point. Depression in freezing point. These are the formulas we have learned yesterday. Today I want to tell you one important question, a reasoning question we can say. Okay, especially for the vehicles which are used in the hilly stations, especially for the vehicles which are used in hilly stations like Oti, Shimla, okay, in that places, okay, for the vehicles which are used in hilly stations, okay, in the car radiator, ethylene glycol is mixed along with the water, okay, especially for the vehicles which are going to be used in the hilly station. Hilly stations ನಲ್ಲಿ ಯೂಸ್ ಮಾಡಿದ ವೆಹಿಕಲ್ಸ್ ನಲ್ಲಿ ಆ ವೆಹಿಕಲ್ ರೇಡಿಯೇಟರ್ ನಲ್ಲಿ along with the water we are mixing ethylene glycol. Along with water we are mixing ethylene glycol. For which purpose we have to mix the ethylene glycol there? ಎದಕ್ಕೆ ethylene glycol ಅನ್ನೋದು ಮಿಕ್ಸ್ ಮಾಡಬೇಕಾಗಿತ್ತು? What is the function of ethylene glycol? So you know that when to the water when you are adding some solute, its freezing point what happens means decreases. For example, I take it here. You can imagine this basis as some OT. So here the temperature in this village, in this city is how much means minus 3 degrees centigrade. In OT the temperature is how much means minus 3 degrees centigrade is there. Now if you use pure water in the car radiator, at minus 3 degrees centigrade it will be completely freezed. Okay, the pure water will be completely freezed. That's why we are mixing here along with the water in the car radiator. We are mixing here ethylene glycol. What we are mixing here means ethylene glycol we are mixing. When you add ethylene glycol to the water, okay, when you are adding some solute to the solvent, freezing point what happens somewhat decreases. Now when you added ethylene glycol to the water, now the freezing point of water has been decreased from minus 3 to minus 10 degrees centigrade. But freezing point decrease. So when the temperature comes of minus 10 or below minus 10 only, water will be freezed. Otherwise water will not be freezing. Water will be maintained liquid state only. When you add ethylene glycol, because of adding the ethylene glycol, freezing point of water has decreased from -3 to -10 degrees centigrade. Now when the temperature in the OT, when it comes below -10 degrees centigrade, then only water will be freezed. Otherwise water will not be freezed. It will remain in which state only, means liquid state only. So here what we can say about ethylene glycol? Ethylene glycol is causing the water to freeze up, or it is preventing the freezing of water, means you can understand here ethylene glycol is preventing the freezing of water. Ethylene glycol is preventing the freezing of water. That's why ethylene glycol is called as the anti-freeze, we should call. Ethylene glycol is called as what, means anti-freeze. Okay, hi students, all of you. Okay, that's why ethylene glycol is called as what, means anti-freeze. Okay, understand students? Okay, what is the purpose of adding ethylene glycol to the water, especially in the radiators of vehicles which are used in hilly station? Especially in the radiators of vehicles which are used in hilly station, why we should add ethylene glycol to the water? Means, okay, if you use the pure water, it will be freezed at that time, because in the areas the temperature will be maintained how much? -degree centigrade. Okay, if you use pure water, now pure water use ಮಾಡಿದ್ರೆ ಆ pure water ಏನಾಗುತ್ತಮ್ಮ freeze ಆಗಿ ಬಿಡುತ್ತೆ. Okay, that's why we should not use the pure water, especially in the vehicles which are used in the hilly stations like Ooty, Shimla, those places. ಅದಕ್ಕೆ ಆ ವಾಟರ್ ಜೊತೆಗೆ ನಾವು ಏನು ಮಿಕ್ಸ್ ಮಾಡಬೇಕಂದ್ರೆ we have to mix ethylene glycol. When you are mixing ethylene glycol in the water, now the freezing point of water has been decreased from -3 to -10 degrees centigrade. So when the temperature becomes less than -10, then only water will be freezed. So until the temperature becomes -10, water will be maintained in state only, means liquid state only. So that's why we are mixing ethylene glycol into the water, especially in the hilly stations. Here what is the ethylene glycol? What is the role of ethylene glycol? Means ethylene glycol is preventing the freezing of water. Ethylene glycol is preventing the freezing of water. ಅದಕ್ಕೆ ethylene glycol ನಾವು ಏನಂತ ಕರಿತೀವಿ ಅಂದ್ರೆ anti-freeze. For that reason only ethylene glycol is called as what, means anti-freeze we are calling. Ethylene glycol we are calling as what, means anti-freeze. Understand? Hope students you understand the concept here. So when you are okay, if you use pure water directly, because of the low temperature in the hilly station, the water will get freezed in the radiator. Water which is present in the radiator, it will get freezed. Okay, we have to prevent that freezing. That's why we added ethylene glycol to the water. The same thing, that's why we are calling ethylene glycol as what, means anti-freezing agent we are calling. What we are calling is anti-freezing agent. The same logic okay, you can also apply to the, especially in the European countries like you can say, okay, in some places of America, Russia, Canada, okay, in the places in the winter season, the road is totally covered with ice. Ice. Okay, I want to clear this ice fastly, means I want to clear this ice fastly, means what we are spraying on this ice means, we are spraying here NaCl or calcium chloride. In order to clear this ice fastly present on the road, what we are spraying on this ice means we are spraying here sodium chloride or calcium chloride. For which purpose? What is the role played by here sodium chloride or calcium chloride? Means the same thing, the same logic here. When we are adding some non-volatile solute to the water, its freezing point, what happens? Somewhat decreases. The same logic here also you can apply. Suppose in that country, in that case now, -3 degrees centigrade is the temperature. When ice is present on the road, in that country, what is the temperature we can assuming, means -3. When you added salt or calcium chloride to the water, when you are adding some non-volatile solute to the water freezing point, what happens? Some decreases. So now water freezing point decreases from 0 degrees to what is the freezing point of water? 0 degrees. Now when you added salt or calcium chloride to the water freezing point decreases from 0 degrees to -10 degrees centigrade. So until the temperature becomes -10, the water will be present which state only? Liquid state only. When the temperature becomes less than -10, then not it will be converted to solid state. So by using that logic, okay, when the temperature becomes less than -10, then only it will be freezed. Until that temperature, water will be present in liquid state only, and so all the ice will be fastly melted and it will be converted to which state? Means liquid state. That's the reason that NaCl or calcium chloride. NaCl or calcium chloride we are calling as what means de-icing agent we are calling. What we are calling means de-icing agent we are calling. Ethylene glycol we are calling as the antifreeze, whereas NaCl or calcium chloride we are calling as what means de-icing agent we are calling. De-icing agent. Okay. So this is about this concept here. These are the two important reasoning 1 mark questions. Okay, they will ask in the examination. What is the purpose of adding ethylene glycol to the water, or what is the purpose of adding NaCl to the water? If such questions are asked, means what's the answer we have to say means by adding ethylene glycol to the water or NaCl to the water, the freezing point of water will be decreasing. The freezing point of water will be decreasing. In order to decrease the freezing point of water only, we are adding here ethylene glycol or NaCl. So this is the theoretical part of the depression in freezing point. Today we shall do some numerical problems related to depression in freezing point also. So we shall start the numerical problems. Okay, first problem I am explaining here. Page number 52 in the textbook. Question number, example number 2.10. Page number 52, example number 2.10. I am reading the question once you can see. 1 gram of non-electrolyte solute. 1 gram of non-electrolyte solute dissolved in 50 grams of benzene. 1 gram of non-electrolyte solute dissolved in 50 grams of benzene lowered the freezing point of benzene by how many kelvins means 0.40 Kelvin. Okay, when 1 gram of solute is dissolved in 50 grams of benzene, weight of solute how many grams given means weight of solute they given us how many grams means 50 grams. When it is dissolved in 50 grams of benzene, 50 grams of benzene, the freezing point has been decreased by how much means the depression freezing point given 0.40 Kelvin. Depression freezing point how much given means 0.40 Kelvin has given. Next, the freezing point depression constant of benzene. The freezing point depression constant. Freezing point depression constant is what amount? Kf. Kf for benzene how much given means 5.12 Kelvin. Depression freezing point. Depression constant how much given means 5.12 given. We have to calculate the molar mass of the solute. We have to calculate the molar mass of the solute present in the solution. So we have to calculate the molar mass of solute present in solution. It means that we have to calculate what was small m we have to calculate. So you can apply the formula of depression in freezing point. What's the formula we are having for depression in freezing point is delta TF is equal to Kf into small w by small m into 1000 by capital W. This is the formula we are having. Delta TF is equal to Kf into small w by small m into 1000 by capital W. This is the formula we are having. Depression freezing point. How much given the question means 0.40 Kelvin has been given. 0.40. KFL how much given means 5.12. Weight of solute is 1 gram. Molecular mass of solute we don't know. We have to find it out. So weight of solid, how many grams given is 50 grams given. Weight of solid, how many grams given is 50 grams. 0 will be cancelled. 5 will cancel 100. How many times means 20 times. M is equal to 20 into 5.12. 20 into 5.12 divided by 0.4. 20 into 5.12 divided by what we got it means 0.4 we got it. Do this calculation. If you do this calculation, how much we are getting this molar mass means the molar mass of solute is found to be 256 grams per mole. So the molar mass of solute is found to be how much means 256 grams per mole. So this is the question number, okay, example number 2.10 in our textbook. Okay, next. We shall move to the next question. We are moving to the next question. Example number 2.9. Example number 2.9. 45 grams of ethylene glycol is mixed with 600 grams of water. 45 grams of ethylene glycol is mixed with 600 grams of water. Two questions are given here. What are the two questions given here means we have to calculate the freezing point depression as well as we also have to calculate the freezing point of solution. We have two questions are given. We have to calculate freezing point depression as well as we also have to calculate the freezing point of solution. So what are the data given here means how many grams of ethylene glycol means 45 grams. 45 grams of ethylene glycol. W is equal to 45. Next. Ethylene glycol. You know the formula of ethylene glycol. Ethylene glycol means the formula is C2H6O2. C2H6O2. Its molar mass will be how much? 2 carbons means 24. 6 hydrogen 6. 24 plus 6 30. Okay, if you not see, I am writing once again here. Small w is equal to 45. Molar mass is equal to 2 carbons 24. 6 hydrogens 24 plus 6 30. 2 oxygens 32. Totally we are getting 62. 62 in how many grams of water? They dissolved in 600 grams of water. And molar mass of water. Molar mass of water is how much means 18. Molar mass of water is 18. This is the data given in the question. And Kf value also you can order for water. Kf for water is 1.86. Kf for water is how much means 1.86. We have to calculate two things here. First thing, we have to calculate the freezing point depression. We have to calculate the freezing point depression, and later on we have to calculate the freezing point of solution. Firstly, we shall calculate the freezing point depression. You can see freezing point depression. What is the formula we are having means freezing point depression. What is the formula we are having means delta TF is equal to. Okay, we know the depression freezing point formula. It is the formula for freezing point depression. Delta TF is equal to Kf into W by M into 1000 by capital W. Kf value how much means 1.86 W weight of solute 45 by molar mass of solute 62 into 1000 by how many grams of water means 600 grams of water. 2 zeros will be cancelled, and here you can cancel this one. This is 5 times and this is 3 times. Okay, and this 3 will cancel this 45. How many times is 15 times? 1.86 into 75. 1.86 into 75 divided by what you got here means 62 you got. 1.86 into 75 divided by what? 62. 1.86 into 75 divided by 62. How much we got? It means this answer 2.25 we got. Depression in freezing point is going to be how much means 2.25 Kelvin. 2.25 Kelvin. One more question they asked in the question. One more thing they asked in this one. Okay, what is the one more thing they asked means we have to calculate the freezing point of solution. We have to calculate the freezing point of solution. We have to find that one also. Delta TF is equal to T0F minus TF. T0F minus TF. We have to calculate the freezing point of solution. Freezing point of solution means TF we need to calculate. TF is equal to T0F minus delta TF. T0F minus delta TF. T0F value is 273.15 minus delta TF. Delta TF is 2.25. 2.25 if you do this calculation. If you do this calculation, how much we are getting the answer means 270.9 Kelvin we are getting the answer. The answer we are going to get here how much means 270.9 Kelvin. It is the second problem. Example number 2.9. Example number 2.9. Okay. Good afternoon. Next we are doing this question. Okay, problem number in text question, page number 55, question number 2.11. Calculate the mass of ascorbic acid. Calculate the mass of ascorbic acid. Ascorbic acid formula has been given in the question. C6H8O6. C6H8O6 to be dissolved in 75 grams of acetic acid. To be dissolved in 75 grams of acetic acid to lower its melting point. To lower its melting point by 1.5 degrees centigrade. To lower its melting point by 1.5 degrees centigrade, and Kf is equal to how much given means 3.9. Now to understand the question, students, okay, the solvent we taken is 75 grams of acetic acid. The solvent we taken is 75 grams of acetic acid. To the 75 grams of acetic acid, by adding how many grams of ascorbic acid? By adding how many grams of ascorbic acid? The melting point should be decreased by how much means 1.5 degrees. The melting point should be decreased by how much means 1.5 degrees. So delta TF. We have to get the delta TF value how much means 1.5. And KF value given in the question 3.9. KF value given in the question 3.9. We have to dissolve how many grams of ascorbic acid? That's what we have to find out in the question. How many grams of ascorbic acid we need to dissolve? They given the molecular formula of ascorbic acid. What's the molecular formula of ascorbic acid given? C6H8O6. It means what will be the molecular mass amount? C6 means 72. Molecular mass is equal to ascorbic acid C6H8O6. 72 plus 8, 80. 80 plus, okay, oxygen, 6 oxygen means 16 and 96. That is totally we are getting 176. We are getting the molar mass of ascorbic acid. Molar mass of ascorbic acid we are getting 96. And weight of solvent, how much given means 75 given. Weight of solvent, how much given means 75. So we shall find it out. See, we shall do this question. So apply the formula for depression in freezing point. Delta TF is equal to Kf into small w by small m into 1000 by capital W. Delta TF, depression in freezing point, how much we should get means 1.5. Kf value, how much we should get means 3.9. Small w, weight of solute, that's what we have to find out in the question. Molar mass of solute. Molar mass of solute is 176 into 1000 divided by, what's the weight of solvent given means 75 given. What's the weight of solvent given means 75. We have to do this problem. See, we shall find out the molar mass of the solute. Okay. So can you see this calculation here? This is cancelled how many times means 5 times, and this will be cancelled how many times means with 0.3. With 0.3 I am doing the cancellation. This will be cancelled 5 times, and this will be cancelled how many times means 13 times it will be cancelled. It will be cancelled how many times means 13 times. So W is equal to 176 into 75 into 5 divided by 13 into 1000. 13,000. 13 into 1000, how much we are getting is 13,000. If you do this multiplication, we are going to get the answer 66,000 we are going to get. How much we are going to get this calculation means 66,000 we are going to get this calculation. 66,000 by 13,000, 3 zeros will be cancelled. 66 by 13, that is equal to how many grams means 5.07 grams we are getting the answer. How many grams of, what is the mass of ascorbic acid we have to dissolve means, okay, 5.07 grams of ascorbic acid we have to dissolve. Okay, this is the, okay, numericals related to what means depression in freezing point. Numericals related to depression in freezing point. Okay, so by this we completed 3 colligative property, students. Okay, firstly we discussed about relative lowering in vapor pressure. Second one we discussed about elevation in boiling point, and third one we have discussed about the depression in freezing point. And from tomorrow class onwards we shall discuss about the last and very important colligative property, osmotic pressure. We can discuss it from tomorrow class onwards. Okay, thank you very much, students.